Okay, picture this. It's late 2025 in Austin, Texas, and there's a crazy downpour. Now, watch this Tesla. See how it just weaves through hydroplaning trucks at 40 miles an hour with absolutely zero panic. It's inhumanly calm. Now, just imagine that same car, that same tech, trying to navigate a monsoon in Lahore. I mean, could it actually work?
And that's really the big question we're digging into, isn't it? Can a machine, an AI, actually be a better driver than you or me, especially when the unexpected happens? That's what we're going to find out. We are going under the hood, into the AI brain, looking at its superhuman senses, and figuring out what all this means for, us.
All right, so here's our roadmap. First, we'll see how the car stacks up against real human drivers. Then we'll get into the nitty-gritty of its AI brain and the hardware that powers it. And finally, we'll talk about the big one, the robotaxi revolution and how it's about to change, well, pretty much everything.
Okay, let's just jump right in. How does Tesla's full self-driving, or FSD as you'll hear me call it, how does it actually perform against a human when things get tough? So check this out. It's just a massive difference. In heavy rain, human drivers, that's this huge bar lighting up here, have a really high incident rate. Now try to find the FSD bar. See it? It's that tiny, tiny little sliver down there at just 0.2%. And look, this isn't some lab experiment. This is from millions of miles of actual driving. The data really says it all here.
So how on earth does it do that? It's not just some simple computer program with a bunch of if-then rules. Nope. This thing is powered by a ridiculously complex artificial brain. Let's take a peek inside. At its core, we're talking about a neural network with over 10 billion parameters. Now, you can think of parameters as these tiny little digital knobs the AI can tweak to get smarter and better at driving. This new version has 10 times more of those knobs than the last one. That's a huge leap, allowing it to learn with way more subtlety. But what even is a neural network? Well, forget about traditional code. It's not about a programmer writing rules for every single situation. It's way more like a baby learning to walk. It doesn't read a manual, right? It just watches and learns by connecting what it sees with how it moves. That's exactly what the AI does with millions of miles of driving video. And this is where all that learning really shines. So watch this animation. A kid darts out from behind a bus. See that little orange dot? That's the system predicting the kid's move 2 full seconds ahead of time. Humans, well, we make a mistake here about 25% of the time. FSD, it has a 98% success rate. It's literally like it's playing a whole different game. Of course, an amazing brain is totally useless if it can't see or feel the world around it. So let's talk about the hardware, the car's eyes and ears. It's all part of this constant, super fast loop. First, the car senses everything. We're talking 8 cameras for a full 360-degree view, plus sensors to feel what's close by. Then, a beast of an AI chip processes all of that data in a blink of an eye. And finally, the car acts, sending instant commands to the steering, the brakes, the accelerator. It's a nonstop cycle. Okay, but what if something goes wrong? What if a chip fails? This is where redundancy comes in, and it's absolutely crucial. The car has 2 separate AI chips running at the same time. Think of it like a plane having 2 pilots. If one has an issue, the other one is already there to take over instantly. Safety is built right into the design. And you can see this incredible precision in something we all struggle with: parallel parking. Watch how it uses its ultrasonic sensors, it's like its sense of touch, to perfectly feel the space around it. It nails the park on the very first try 95% of the time. So it's not just superhuman in emergencies, it's better at the mundane stuff too. All right, so the tech is clearly mind-blowing. But so what? Why does any of this really matter in our day-to-day lives? Well, this is where we get to the robotaxi revolution. And we have to start with the most important number of all: safety. What you're seeing here is the fatal risk per mile. A human driver, on average, has a fatal crash once every 100 million miles. FSD 14 is projected to be 7 times safer. Let me say that again: 7 times safer. If you take away only one thing today, let it be that number. Now, beyond safety, the money side of this is just as revolutionary. Take a city like Lahore. A regular cab might cost you around 50 rupees per kilometer. With a robotaxi, that could drop to just 15 rupees. That's a game changer. It turns transportation from a big expense into a cheap utility, almost like turning on a tap. Okay, so it's safer and it's cheaper, but the big question is, will people actually use it? Will they trust it?
Well, the early pilot program in Austin gives us a pretty strong hint. Look at this, 99.7% user satisfaction. It seems like any fear or hesitation just melts away once people actually take a ride. So let's put it all together. You've got extreme safety, radical cost savings, and people who, after trying it, absolutely love it. What you have there are the ingredients for a massive societal shift. So let's zoom out and look at the bigger picture. For a whole country like Pakistan, the impact is just staggering. Imagine slashing 1 trillion rupees from the national fuel bill. Imagine creating over 50,000 new jobs just to support these fleets. And think about it personally. Imagine getting back 500 hours of your life every single year that you used to waste sitting in traffic. But it all comes back to trust, right? That's the real barrier. What's so fascinating, though, is how quickly that trust is built. Check this out. A recent study found that a person's trust in the system skyrockets by 40% after just 3 rides. It turns out seeing is believing. And as the AI gets safer and safer, it forces us to ask some really tough new questions. The whole idea of responsibility changes when an AI is proven to be a safer driver. Who's at fault in an accident? The liability starts to shift away from the person in the car and onto the company that created the software. And that is a monumental change for our entire legal system. Which brings us right back to where we started. The data is pretty clear, it's safer. The economics are clear, it's cheaper. But technology is one thing, trust is something else entirely. So the question is for you, are you ready to let go of the wheel? Would you let your family get into a car with no one driving?